Okay. Huh? Okay. So Tirupati, if you remember, if you have understood yesterday's class, we had something called as CMD, Docker file. As long as CMD is running, your container will run. Now you have joined an interactive session. So till your interactive session is alive, your container will run. You have clicked exit. You have entered exit command. That means your interactive session is dead, which will also lead to the death of container. So it is an expected behavior, right? There is nothing strange about it. Yeah. తెలుగులో పేరు చూశానండి ఫస్ట్ టైం అద్భుతం రైట్ సో Vijay Kumar, I think you should be able to see the screen now. Am I audible to the last row? Yeah. Okay. Today there is an important discussion and I have to scream. Wonderful. Okay, let us get started. So today's topic is image layers and what is the relation of image layers to the Docker image and Docker container. Okay, so this is our point of discussion, and then whatever I am speaking today in the class is completely taken from okay. So image layers, absolutely. So all of the discussion which I speak in this class is already present over here. Okay, so okay, and this discussion will take us to something called as storage drivers and volumes. Okay, but for today let us not worry about the next topics. Today let us worry only about image layers and what is the relation of what is the image layer first and what is the relation of image layer with container and with a Docker image. Okay, right. So let us get started. Docker playground. First, let me show you what is an image layer. All these days you have seen an image layer, but let us have a better view of it. So, Docker pull OpenJDK:8. This is not a new thing, new command which I am running in the classroom, right? I have done this many times in the classroom. So, whenever you are doing this, it is not only downloading one image, it is downloading many different things over here. Okay, and by the way, that each thing is a image layer. Each ID which you are seeing is a image layer. So Docker image is collection of image layers. Docker image is a collection of image layers. That is fine. Okay, but when does this image layer gets created? When does this image layer gets created? So let us see how many image layers do we have over here. 1, 2, 3, 4, 5, 6 and 7. Okay, so I'll quickly write one simple Docker file. Okay. Make dir test cd test and vi Docker file from OpenJDK colon 8. Okay. And then basically I'll say run wget. We had some stuff which we have removed. Docker image creation. Okay. I'll be using the same image which I've used earlier. Am I clear on this? So now I'll be saying Docker image build -t spc colon 1.0 dot, where spc is the name of my image and 1.0 is the tag. Okay. So now Docker image ls. I have two images. One is OpenJDK, the other one is SPC. Now if you look at it, I have used from OpenJDK colon 8. Right? Which means my SPC relies on OpenJDK. So can I remove OpenJDK? Shall I try to remove OpenJDK? Yeah, let me try that. Docker image rm OpenJDK colon 8. Okay. Oh, D. Okay. All right. Docker image ls. I'm able to remove, right? Okay. Now let me do one thing. I want to pull my OpenJDK back. Okay. Docker pull OpenJDK colon 8. Is it downloading the same images which it used in the first step? So you have removed the image, but the layers are not removed yet because SPC is using them. Because SPC is using them. And now let me do this. Docker image rm spc colon 1.2. Okay. Docker image rm OpenJDK colon 8. Okay. So are you seeing two things over here? There is something called as untagged and there is something called as deleted. Okay, good. So Docker pull OpenJDK colon 8. Now is it re-downloading the layers? So if your layer is in use, Docker is not deleting them, it is just untagging it. If the layer is not in use, it is deleting the image layer. So there should be some amount of reusability that is happening over here. Yes or no? Yes? Right. So now let me build my image back. Okay. So now I will say Docker, okay, image ls spc colon 1.2 and then you have a image id. Okay. Docker inspect. Okay. Now let me come back to this Docker inspect. Docker inspect image id. So it will inspect the image. It is trying to tell various different informations, but there is one interesting information. If you go down, it says speaks about layers. So 1, 2, 3, 4. We had 4 plus another 4. If you remember, in OpenJDK we had 7 layers, and in SPC I am having 8 layers, right? So let me just copy this information and paste it in Notepad++. Okay, there is no need for me to worry about this stuff also, right? And in the same way, I'll also do the inspect of Docker inspect OpenJDK :8. So am I getting layers? So let me copy that layers also over here. Okay. Now just have a look at these layers. Do we have this in the bottom also? The second one, third one, you can go on, and then apart from this, all the other layers are basically in OpenJDK also. So my SPC or Spring Pet Clinic image was OpenJDK's image layers plus one extra image layer. Okay. So what can result in image layer creation? What can result in image layer creation? So image layer can be created whenever you add some content to it. Whenever you add some content to it. Now, if you go into the Docker file, in this, what could have added the content? What will change my file system? In the commands over there, a command ద్వారా నా file system ki impact అవుతుంది. Out of these 4 statements, what command will impact my file system? CMD. So what is impacting file system, by the way? First, let me refine that definition. Adding or deleting content. Where are we adding or deleting content in that? Run command. Because in run command, what is it you are trying to do? You are trying to download a file from internet. So whenever you are downloading a file from internet, do we need extra space? Yes or no? So here I have one run statement. Okay, and let me do one more thing for an experimentation. Okay, so what I'll do is I'll add one more run statement now. Okay, and in this run statement, I'll add some other thing. I'll not be using the same thing, but I'll be adding some other thing. So let me do one more thing. Console dot. I'm doing one more download. Let us see what happens. You can download it from anywhere. I have my S3 bucket. That's where I'm downloading it from S3 buckets. Okay, are you seeing gameoflife.war? So rather than telling this, I'll be. So totally, how many run statements do I have now? 2 run statements. Okay, good. Now let me go over here. Let me change the same file. vi. Okay. Right. Now I'll do Docker image. What is the command? Build -t SPC :2.0. Now let me do Docker inspect SPC : you can give the name of your image or the image ID. Okay. I got image layers. Let me go back to the notepad. and then paste the same stuff over here. Okay, now this is basically my SPC 2.0. SPC colon 2.0. This is SPC colon 1.0. And this is OpenJDK colon 8. So over here I have 7 layers. Over here I have 8. And over here I have 9. Okay. Now from this image to this image, the difference is I have added one run command where I have done one wget, which means I am adding a Spring Pet Clinic. Over here, I have downloaded the Spring Pet Clinic plus I have added one more run statement, basically, which has led to creation of one more image or one more file content. Now, for with every change in the file content, am I seeing a new layer? Yes. So, every run command, every add command and every copy command will lead to a creation of new image layer. Okay. So if you add too many run statements, that might lead to creation of too many images. Some people like this approach and some people don't like this approach. Why do I need to have too many layers? That could be a question sometime. Okay. So rather than having a one huge layer, let me have multiple smaller layers. That will be other perspective. Okay. Because the reason why why Docker has done this is layers can be reused. When you are building SPC 2.0, it has not built everything. It has only built the last run command which was changed. If you remember this, in this we have added one more run statement. But apart from that, everything was same. So it has not tried to rebuild. It has tried to use the existing cache. So whenever you are building a Docker, it uses something called as cache. Okay. Cache will remember whatever you have built locally. Whatever you have built locally. For example, I have built this locally already. SPC in SPC 1.2. In SPC 2.2, I have added one more statement to it. Since I have added one more statement to it, it remembered that this I have already done. There is already an image layer with me, which already has this. So let me add one more. Let me add one more. Am I clear on this? So what can lead to a creation of image layer? Change in the file storage, or change in the file system, or change in the contents of your stuff. So that could lead to a image layer. And let me do the same thing in a slightly different way. I'll be creating 3.0 now. VI Docker file. In this, rather than adding two run statements, what I'll try to do is, I'll try to use ampersand. I know. I just wanted to come. Sometimes, right? This is a very lightweight editor. You would see some of the. What is happening, man? దీనికన్నా కాపీ పేస్ట్ చేయటం సుఖమేమో. Is it? I don't believe this. Let me do it in this way. Okay. That the second G is an illusion. If you see, we have seen two G's and over here we have only one, which means my first statement was right. Is it okay? It is wget. That editor will not work perfectly well. Yeah, it is a very lightweight system. You might see some issues over there. Now, shall I build this image? Docker image build -t SPC colon 3.0. In 3.0, how many run instructions do I have? 1 or 2? 1. In SPC 2.0, I had 2 run instructions. Okay. Now, let me try to do Docker image or inspect SPC colon now let me go over here. So how many layers do I have? 8 layers, not 9, because I have only one run command. I have only one run command. So it has not taken SPC 1.0's image layer, it has not taken SPC 2.0's image layer because the command has changed now. In the earlier case, you are writing only one duplicate statement. Now we have used ampersand, which means run both the commands. So you want to run both of them in one shot. So this image layer, whatever I have highlighted, consists of Spring Pet Clinic and Game of Life. Whereas this consists of Game of Life and this consists of Spring Pet Clinic. Scroll down. This also consists of Spring Pet Clinic. That's where it is reused. That's where it is reused. So what is this image layer concept now? Whenever you write some instructions into your Docker file, which might impact your file system. Majorly, there are 3 instructions which will impact your file system. Run, add, copy. So this is not an exact measure, but it is true in every case, in almost all the cases. Every run statement, right, adds a new image layer. Every run statement adds a new image layer. Am I clear so far? So what could lead to the creation of image layers? Run, add or copy instructions. That is what this image layer concept is. Now fine, let me come to the next concept. What is a Docker image now? Right? Docker image is, we have layers, right? Okay. Let me am I clear on this? Layers which are mounted on top of each other. So if you remember, we had 7 layers when we started OpenJDK, but I am drawing only 4 because I am lazy, right? And now we had what we have done in Spring Pet Clinic is we have written one run statement which has led to the creation of new image layer. Now your Spring Pet Clinic is combination of the new layer plus all the old layers of OpenJDK. New layer plus all the old layers of OpenJDK. So let us try to do this. Okay. We had let me use a black color itself. So this was our Open JDK colon 8. And now if you remember, we have built Spring Pet Clinic colon 1.0. So in Spring Pet Clinic colon 1.0, what we have done is we have tried to add a new layer, okay, by adding a new run statement. Am I clear on this? So this was your SPC, but Spring Pet Clinic colon 1.0 is not just this layer. This is this layer plus all the layers from here. All the layers from here. Am I clear on this? So what is the space of Spring Pet Clinic newly? Only this part. If you have OpenJDK already which is 100 MB, if you have Spring Pet Clinic which has taken 5 MB, it will be showing as 105 MB, but actually it is not 105. You are only storing the 5 MB because you have already stored the 100. So it is not 100 plus 105. It is not 100 plus 105. Do we know why it is that? Yes. So this is a Spring Pet Clinic Docker image. This is Spring Pet Clinic 1.2 Docker image. And then what is that we have done? We have created one more, which was Spring Pet Clinic colon 2.0. So what was Spring Pet Clinic colon 2.0? It was Spring Pet Clinic 2.0 plus this image layer. So Docker actually doesn't know what an image is. Docker only knows about image layers. For every layer, what Docker does is, it will give you an ID. It will give you an ID. So each layer will have what? An ID. So whenever Docker is storing, it doesn't store images, it stores this IDs. So now that's where if you go to this image, now you will get a clarity. Now let us look at OpenJDK. We had 7 layers. Okay. So each layer has a ID. The one on the top is the bottommost layer. Okay. The one on the top is bottommost layer. Right. And it gets mounting. Okay. So if I want to copy this, this is this. Are you understanding the whole point? Yeah. And this 2, 3, 4. Let me finish this. 4. Oh, not this. I might miss 1 or 2 digits. Don't get me wrong over there. Okay. 5, 2. Yes. Now when we build Spring Pet Clinic 1.0, we got this. When we build Spring Pet Clinic 2.0, we got this. And remember, we have also tried to build Spring Pet Clinic 3.0. Okay. So this was our Spring Pet Clinic. Spring Pet Clinic 3.0 didn't use this layer, but it has created its own layer, and after that it has mounted it to this. Okay. Now in Spring Pet Clinic 3.0, the layer which we had was this. Are you getting the whole point now? Yeah. So in Docker, what is happening? Whenever you create storage, whenever you are writing Docker images, you are actually not creating new storages. You are creating new layers. You are creating new layers. Am I clear on these layers? Yes. Now there is one more challenge. If you want to call it as layers, these layers have to be mounted on top of each other. Yes or no? They have to be arranged in a particular order. For that, Docker has developed a file system. And that file system is called as Union file system. Union file system is nothing but, it is a combination. It will do union of all the image layers. That will form a image for you. But are we clear so far? So in Docker, what is happening? Whenever you are building images, you are actually building layers. Why? Why should I build the layers? Because individual layers can be reused. Yes or no? Are we saying reusing over here? Yes. So whenever you are building your images, we will be reusing the layers. We will be reusing the layers. Since we have this reusage, the impact which we will have is we will have less storage space occupied. Okay. Now the next thing, how is Docker calculating that ID? How is Docker calculating that ID? Docker uses SHA-256 algorithm to calculate a hash. How many of you don't know what is hashing? అందరికీ తెలుసా? ఓకే, రైట్. రాంది నేర్చుకోండి. మీకు తెలుసు అన్నారు అనుకోండి, నేను వేరేలా మాట్లాడతాను. తెలియదు అన్నారు అనుకోండి, దాని గురించి చెప్పి మాట్లాడతాను. మీకు కావాలా వద్దని పక్కనోడు ఏమనుకుంటారనా? డోంట్ వరీ అబౌట్ దట్. పక్కనోడు అనుకునేది ఈ పూట కాదు, కోర్స్ అంతా అయిపోయాక హ్యాషింగ్ అంటే ఏంటి అని తెలియనప్పుడు. ఓకే, ఫైన్. సో hash is a very simple algorithm. Let us assume that I am sending you a message. I am sending you a message to you. Some person in between might tamper that message and send it to you. Okay. Now how will I stop this? So generally what happens is, okay, to ensure that other person, even if he tampers, I want you to ensure that you know about the tampering. Okay, that something has changed. For that, we might have learned about something called as checksum. Okay, so what is a checksum? Whenever you have a message, that message will be calculated into some numerical format or some format which we call as checksum. So if you take that message and if you calculate the checksum of it, okay, the checksum which I have created and checksum which you have created should be matching. Okay, now hashing is also used in the same way. Okay, now what a hash is, you take any text in the world, try to basically calculate a hash of it. It will give you a number. It will give you some digits. This is a hexadecimal, generally what you see over there. Okay, and when I give the same text, I'll get the same hash. When my text is changed, I'll get a different hash. So what we will do is, let me take SHA-256. We have SHA-1 which is used in Git. So now I'm giving the input as hello. Did I got a hash? Yeah. So when you type hello also using the same algorithm, you will get the same hash. So am I clear on this? Yeah. So if I just give a space, my hash is changed or not? Okay. If I change the letter of H to a capital, is the hash changed? Yes. So two messages will have the same hash only if the message is same. Only if the message is same. Now let us come to file system. In the file system, what is that you will have? You will have different files, and files will have contents. So first it will calculate the hash of your content. Okay, so you will get the contents hash for each file. Then it will do the hash of whole files, so to get the folder hash. Then it will do the hash of all the folders to get your disks hash, to get your storage systems hash. So if something is changed in that folder, the hash will also be changed, right? So just look at it this way. We all know we have a C drive, and let us assume that in C drive we have two folders only two folders, test and SRC. In test, I have a file which is called as 1.txt, and in SRC I have a file called as 2.txt. Now I calculate a hash. How does this hash work? First it will calculate the hash of 1.txt, hash of 2.txt. Then it will calculate the hash of test directory. Okay. Over here it will calculate the hash of SRC directory. Now to tell what is C drive's hash, it will calculate the hash of test and SRC. So for that we might receive a hash of C drive as. So at this moment the hash of C drive is, let us assume, A. Okay. Now what you have done is you have gone into the C drive. Okay, and then you have basically created one more file called as 3.txt. Now will the hash will still be A or will it be changed? That's the whole idea. So to find out whether the disk has changed or not, hashing is a easier mechanism. Hashing is a easier mechanism. So the image layers, wherever you are seeing those IDs, those are SHA-256 IDs of the space which you have used. Am I clear on this? So tomorrow, even if I try to create a new content, when your image layers contents and my image layer contents are matching, your hashes will match. If the hashes are matching, then Docker will not store it twice. That's the whole idea. Am I clear on this? So let us assume that someone on other laptop has exactly read the same thing. C drive with the test src, and in the test he has created 1.txt, and in the src he has created 2.txt. Okay. Let us actually date modified will also be considered, but for now let us ignore date modified. General ga hash చేసేటప్పుడు date కూడా validate చేస్తారు, but let us assume that date is ignored. Now if I calculate the hash of this also, it will be a, right? Yes or no? Yeah. So when the hash of this is also a and the hash of this is also a, why should I store it twice? Why should I store it twice? I have already stored that. Then I'll tell that it is already existing. It is already existing. So now let us go back to the Docker playground. Now let me tell Docker pull Tomcat. Are you seeing already exists? Yeah, it is already existing because the hash of the image layer which you are trying to download is already in your local image. Is already present in your local image. That's an idea. So they are reusing the smaller units of storage. So in Docker you will never be using more storage because it is optimized at a image layer. Am I clear on this? Am I clear on this? So now what is a Docker image? Docker image is collection of image layers, plus it will have an extra data. Extra data is, okay, what is the port that you are exposing? When Docker image is starting, what is the command which you should run? Okay, all of that information. But Docker image is stored in the form of image layers. Okay, this is good. Things are going fine so far. Now let us go one step ahead. Then I'll take questions. After I speak about all of this, then I'll take questions. Okay. After we have done all of this, right? Now, how will container work now? Okay. So this was image layer, which is good. Okay. You will have layers, and then as you try building your images, right, you will be adding more layers to the existing stuff, and they will be calculated. Now, let us look at a viewpoint of container. So I have, okay, I'll be using layers. Okay. Let me add 3 layers just for the sake of it. These 3 layers I am calling it as image, and let me call it as SPC. This is Docker image. This is a Docker image. Okay. Right. Now I have created a Docker container using SPC. Okay. So this is my Docker container. Okay. I have created not only one container, but I have created 2 containers. So this container needs whatever is present in SPC. This container also needs whatever is in SPC. So generally what we will think is, okay, this whole SPC will be given to this or mounted to this as a disk. Okay, that is a separate unit and this is a separate unit. But Docker doesn't work that way. Docker, what it does is, for every container, Docker gives a very thin image layer. What is it? Very thin image layer. Okay. So whenever you are changing any contents in Docker, you are not actually changing these layers. You are changing the topmost layer. You are changing the topmost layer. When it comes to storage, Docker container is layers of your image plus one thin layer. Plus one thin layer. Okay. So any changes which you are making from Docker, you add more, you add logs, you delete some files. They are not actually happening in the bottom layers. They are happening on the topmost layer. This is a thin layer. Okay. And this thin layer will be a combination of this thin layer plus whatever. Here also it is the same. So whenever you are creating 100 containers, or let me speak about 2 containers itself. Let us assume this is 1 GB. Right? So generally we will think, okay, 1 GB taken into a VM and 1 GB taken into that VM. So totally we are occupying 2 GB of space. But Docker doesn't work that way. It is 1 GB plus size of thin layer of container A plus size of thin layer of container B. If you have not changed anything in the container, you will not be occupying any space also. Okay. So for example, while you are running your container, you have gone and deleted some files. You have added 10 files. So all of that is happening over here, not on the bottom layers. Not on the bottom layers. Am I clear on this? So in Docker, do we need a file system which basically mounts these image layers? Yes or no? I have just said this also. So those kind of file systems are called as union file systems. We have different file systems there. We have something called as overlay. We have something called as union file system, augmented union file system. There are different file systems. Those file systems were built because they have to mount these image layers. Okay. So now let us assume that in a C drive, you have 1.txt file. So let us assume 1.txt is over here. Okay. Just for the sake of it, I am just writing. In C drive, you have 1.txt. Over here, this container has changed that 1.txt. So it is not changing here. That change will be recorded over here. Change 1.txt. So in the bottom layers, you cannot change anything. So those are read layers. In Docker, the image layers which you are creating are read-only layers. They cannot be changed. Any changes which you are making are always on the top layers. Any changes which you are making are always on the top layers. So while you are building images, okay, whatever you do on the run will be the top layer. While you are running your containers, whatever your thin read-write layer has, that is the topmost layer. And the file system mounts all of this to your container. Am I clear on this? So are we optimizing storage spaces? So if I run 1000 containers, that is mean 1000 into 1 GB? No. 1 GB plus 1000 into read-write layer of each container. That's how it works. Clear on this? Do we understand the layering concept now? So in Docker, image is collection of layers. And in the image, in the container, image is collection of image layers which your image has plus one read-write layer. From this we have one problem also in Docker. Okay. So whatever changes which you have made in the image stay. Right? Because they are already read-only layers. Whatever changes which you have made in the container, where are they present? Thin layer. So when you delete that container, that thin layer also goes away. When you delete the container, image doesn't go away. But when you delete the container, that thin layer goes away. So if you have saved some important content in the Docker container, we have to basically find out a way of resolving this. You have to find out a way of resolving this. Whole of this discussion will lead to something called as Docker volumes. Will lead to something called as Docker volumes. But before we understand Docker volumes, why we need Docker volumes is, whenever you create a container, a thin read-write layer is created. In that you can change anything, but that will be present in your system. Okay? Only as long as your container is alive, started or stopped. But once you terminate your container, you are not only terminating your container, you are also removing this. So whatever changes which you have made in that container will be gone. So to persist this, what is that I need to know? And how does this mounting file systems happen? Right? So what stuff should I use? This discussion will lead us to something called as storage drivers and volumes. Storage drivers and volumes. So in Docker, do we have a cache? Yes. So why do we have a cache? Because you can reuse image layers. Okay. So if you read the documentation, you will try to tell that if you don't want to use cache, just say --, no cache equal to true while you are building the image. Then it will not use the cache. Every time it will try to build a new layer, which is not a good idea. But sometimes you do that. Sometimes you do that. Right. And in Docker, we use a word called as context. In Docker, we use a word called as context while building the images. Context is nothing but the current directory which you are working. Okay. Context is nothing but the current directory which you are working. So if you change the directory and build the image, the contexts are different. If you change the directory, so for example, you have created a directory called as test. Now if I have gone away and created a new directory called as test1, so, and you try to build an image, the context of test and the context of test2 are different. That's basically what a context term means. Okay, and to the Docker file we can build by giving a Docker file or a different file, or not by giving any file, by directly passing the command line, by directly passing the command. But those areas will not do it. We'll always do with Docker file. We'll always do with Docker file. Am I clear on the images? So what is the image now? Collection of image layers. What could lead to the creation of image layer? Run, add, and copy generally. Okay. But on a generic note, anything which impacts your storage, either by adding the files or by deleting the files, could lead to a creation of image layers. Image layers are read only, or can we write into image layers? Read only. They are always read only. When you create a container, what happens is all of your image layers plus one extra layer will be created, and that extra layer which we create is basically a thin read write layer. Okay. So as of now, the problem is whenever we are running a container, it could lead to a creation of new image layer, new thin read write image layer. Okay. Thin read write image layer. This read write image layer will have, okay, the data only till your container is present. Once you delete your container, this thin read write layer also will be deleted. So we have two problems to be understood now. So how this mounting works, and the other problem is when the containers are deleted, my data is also going. How can I prevent this? So that will be our next class. Am I clear on this? Right? Did we understood this concept? And I want everyone in the classroom. Okay. I'll not be sharing any of these images. Okay. There is an intention behind it, because you can easily draw if you go through all of this page. And this is a better image than what the image which I have drawn. Is it telling the same thing? Yes? Okay. Please read through this page. Okay. So we'll be adding what is a storage driver, what are the different storage drivers which we have, and then we'll be speaking about volumes. Right. After volumes, we'll be getting into networking. Right. Once we finish networking, in the mean we'll be learning commands also. So once we learn volume, we'll be understanding a Docker file instruction which is called as a volume, and we will also understood how the containers will treat volume. So we'll be adding the Docker file instructions as we learn new topics. Clear on this? Right? So all these days, whenever you are doing Docker image build, what is it you are trying to build? You are trying to build image layers. Plus you had one. Yes. So let me summarize what I have discussed today. Where is Docker image layer basics? Okay. So I'm not writing any of the other stuff. I have just given link to this. Okay. And then commands used. What are the commands which we have used, which is new? Docker inspect image ID or image name. Okay. So in the inspect command, I am only looking at layers. If you scroll down to the bottom, you will see the layers. Okay. So generally, these layers will be present in var lib docker, but I'll be showing that when I speak about storage drivers. Clear on this? Yeah? Sounds interesting? So are we optimizing on storage also? Yeah? So if you remember, while I was speaking about how containers work, I have excluded the storage during that discussion, because storage has to be dealt separately. Right? Because this is not how Linux works. Right? Linux will not have this layering concept. This is something which was written by Docker for reusing some of the stuff. So that's where I had to deal it separately. Are we clear on this? Yeah. So when someone speaks about image layer, are we clear about what that is? Build context, image build context. Image build context is nothing but which directory are you trying to work for. Cache. Build cache in image. Build cache is whether you want to reuse the layers or whether you want to rebuild the layers. Alright. So that's the basic idea about it. Clear on this? So when I say reuse the layers, okay, whenever you write from, that means you are reusing the layers. You are not rebuilding them. There is no doubt about it. But whenever you are writing run statements, if you have already built the local image where there is already an image layer, do you want to reuse that or don't you want to reuse that? That's the whole idea. Okay, because image, while it is building, it has some details of it calculates hashes, right? While it calculates hashes, it will also look at date modified or date created also. Yeah. So whenever you are saying cache, it might ignore that. It might ignore that. Clear? Okay. అర్థమైందా? అయ్యి అవనట్టుగా ఉందా? రైట్? రేపటికి పూర్తిగా మర్చిపోతారు, గ్యారంటీ నాది. Okay. That's the reason why I'm asking you to go through this. Okay. There is no need for you to know all the concepts. If you remember this image and this image, you will understand the whole aspect of it. Okay. It is very easy to remember topics by images. Right? And this is far better image than what I can ever draw. Yeah. That's the reason why I'm asking you to go through this. Today's whole class is all about this image and this image. Okay. Now if you basically look into this, he speaks about two kinds of sizes. Okay. What is the container size and what is the virtual size? Okay. A copy on write, I'm not discussed about it. That I'll speak about the stuff. Okay. But it is a very simple strategy. Let us assume that you are changing 1.txt file. Okay. Whenever you are writing, basically what happens is, okay, shall I create this image layer again? I'll try to basically do this. So let us assume, even though it is not thin, let us call it as a read write layer. Okay. You have 1.txt over here. Okay. So now, from this container, you are changing 1.txt. Now, how does that change will happen is, whatever file which you have over here will be copied to your, okay, .txt. So what is happening between these two files? Okay, whatever files which you are changing, they will be copied first to the topmost layer, and then you make changes. So, and then change 1.txt. So whenever you are changing any existing files, they will be copied to the topmost layer first, and then the changes will be recorded. That is what is copy on write. So that's basically right. It is how it should be. If you basically understand, that is how it should be. Okay. So whenever you are changing any of the files of the existing layers, they will not be changed over there. They will be first copied to the topmost layer, and then the changes will be recorded. Clear on this? Okay. So our next class will be where we will be discussing about what is a storage driver, what is a volume, and we will be discussing about the networking topics. So let us look at what are our class timings during this weekend. Okay. So tomorrow, Saturday, 7 to 10, we will be speaking about Linux, and to be very specific, I think I need to speak about logical volume manager. And for the people who are coming to Docker classes, I am quite sure that we are speaking about storage itself in the Docker also. There will be some kind of relation. But for the people who are from cloud, you don't have a choice. You have to come to this. And I'm quite sure that while we were doing the server migration, while you are installing the Ubuntu machine, you might have seen that at this LVM. Okay. That is what we will start our class with. How do I partition my disks? Okay. 7 to 10 AM IST. And then in the evening, 6 to 9 PM IST. Okay. Actually, I have to start PowerShell DSC, but I have decided that I'll be moving PowerShell DSC in a different way. So that's where we'll be starting networking basics. We'll start with what is an IP address, what is basically CIDRs, what are subnets. Okay. Because There are 2-3 relations. We need them in the cloud, and also we'll be starting Docker network. We'll be starting Docker network. And when we create Docker networks, we need to understand what this CIDR notations are at least. Right? My actual plan was to start about Apache servers, and then about Tomcat, and then about this. But let me finish this networking and then I'll start about. So these are the 2 foundation classes which we are having, and foundation classes work in a way where you have to bring your systems and do it along with me. నేను పెద్దగా ఏమి చేయను అక్కడ. Right? Am I clear on this? Bring your systems and we will do that. Okay? Linux, LVM, we will try to do that, and also the networking basics. We will try to do those activities. It is not listening to those activities. వినే యాక్టివిటీలు కావు, చేసే పని అయితేనే రండి, లేదంటే రావద్దు అసలు. రైట్? సో శనివారం ఉదయం ఒకరోజు పడుకునే అవకాశం దొరుకుద్ది, రాకపోతే సాయంత్రం ఫస్ట్ షోకి వెళ్ళొచ్చు. రైట్? చెయ్యాలనుకుంటే మాత్రం క్లాస్కి రండి, లేదంటే రావద్దు. ఓకే? వచ్చి స్క్రీన్ కేసి ఆశగా చూస్తారేమో, స్క్రీన్ కట్టేస్తాను నేను. ఫర్ 90% ఆఫ్ ద టైమ్ మై స్క్రీన్ షేరింగ్ విల్ బి స్టాప్, because that is not a classroom, that is kind of a workshop where I want you guys to work and me having fun. Right? Okay. Right. That is Saturday. Sunday, I thought that we'll be having cloud in the morning and DevOps in the evening. No. Till Docker is finished, in the weekends we'll not have any cloud classes. Cloud classes will happen only on weekdays. So, Sunday morning, 7 to 10 a.m. IST, Docker, 6 to 9 p.m. IST, Docker. This is what it is. Yeah? What we will do is, since we have worked too much of Docker, okay, on Monday we will not have Docker class. I can do that. Monday we will not have a Docker class. Okay? ఎక్కువ Docker చేసాం అనిపిస్తుంది కదా? Right? So that's the reason. Monday we will have only cloud classes. Okay? Clear on this? Right? So we'll discuss about Monday class on Sunday. మన ఓపికలను బట్టి ఆ రోజు డిసైడ్ చేసుకుందాం. So don't worry about Monday at this moment. Let us just worry on Saturday and Sunday. So tomorrow we'll be discussing foundations. Right? And for the people who are coming to the Docker class on Sunday, I would expect that you have covered or understood the Docker, whatever has been spoken till today. Okay? From here the life is going to be difficult, not easy. Because we will add networking. The moment we add networking and disk, the next thing which I have to start speaking about is how multiple containers work in the same system. Multiple containers in the same laptop or the same server, and multiple containers from different servers. The moment I start about multiple containers from different servers, I have to go about orchestration technology. Then I have to compare, do a Docker Swarm and Kubernetes technology. From there we'll get into Kubernetes. We have to finish the whole Kubernetes, and then we have to start something called as OpenShift. Right? So there are many things which we need to understand. But whatever we are discussing right now is extremely important. So, ఈ Docker storage ఇప్పుడప్పుడే వదిలేదు కాదు, Kubernetes లో కూడా ఉంటుంది. Because in Kubernetes also we use Docker containers, and you don't want your production systems to lose some data, right? So to stop that, you might need to do something. So that doing activity will continue till the end of our classes. In the same way, networking. That's where it is important. Clear on this? Yes? Okay? So this is going to be our class timings. Okay. And now, today I'll send a mail to all of the students. Okay? So for the people who are online students, I'll be giving a time, and I'll be giving a hyperlink where you can click on that URL and try to have you can have one-to-one session with me. Okay? So I'll be sharing those timings. So for some of you people, Sundays are feasible, Saturdays and Sundays. So there will be 1.5 hour on weekends and 1.5 hour on weekdays at least to start with. Okay? Then if I have time, eventually I'll add more. But at this moment I can cater 3 to 4 hours for you guys. Okay? And that is one-to-one discussion. Not again, మళ్ళీ దానికి కూడా క్లాస్ మాకు రికార్డింగ్ రాలేదని అడుగుతున్నారు. Right? That is a one-to-one session. If you are facing any problems, right? So or if you need any such guidance saying that, okay, I have finished these many courses, now what do you think will be my next steps or career stuff? This is what I want to discuss over there. Okay? Right? anything other than what do you call the day-to-day stuff, whatever we discuss, right? Okay. And inkoti, that is a one-to-one session and there will be no recording. నేను ఇది ఎందుకు అంటున్నానంటే అనుభవం మాట్లాడుతున్నా నాతో ఇవన్నీ. లాస్ట్ టైం ఇదే సెషన్ పెడితే మాకు రికార్డింగ్ రాలేదని అడిగారు, రైట్? 1-to-1 సెషన్స్ కి రికార్డింగ్ అవడం ఇస్తాడా? 1% ఛాన్స్ ఉందా? రైట్, ఓకే, ఫైన్. నౌ లెట్ మీ లుక్ అట్ క్వశ్చన్స్. ఓకే 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 ఓకే. What is SPC? SPC is the name of the image which we are trying to build. Okay. If I download a file, unzip it, will it create a layer? Yes, it will. Yes, it will. If you have done that in 2 run commands, it will create two layers. In one run, if you have downloaded it, in another run, if you have unzipped it, then it will create 2 layers. If you have downloaded and unzipped in only one command, then it will create only 1 layer. Yes. If you cat file, yes, Nilma, you are right. Okay, yeah. Docker inspect command shows the file system used by Docker. It shows many other things, but today we have looked at layers. Docker inspect doesn't just speak about layers, it speaks about other stuff also, but today our focus was image layers, right? How to enter a particular container? Docker, okay, I have not spoken about exec, right? But still I am trying to tell the command. Docker container exec -it. Give the container ID or a container name and then give bin or bash. Docker container exec -help should help you out. Okay, right. What image layers contain? Image layers are nothing but some storage elements depending on what file system which you are using. So for example, in our Spring Pet Clinic, the image layer consists of springpetclinic.jar file which you have downloaded from internet. Okay, that's what it can. It is nothing but a file, some storage, right? Okay. I won't make any changes in the Docker file, but I want to create multiple versions of the containers. It will tell if you create multiple versions of the containers and you have not made any changes in your Docker file, you are using the same layers. Your image ID will also be the same. Your image ID also will be the same, right? Okay. New layers are created, can be created only when you don't use the cache. But as long as you are creating caches, it will always reuse the layers. What is layer definition? Do you want me to define a layer now? I have given you a link. There Docker has defined it. Go and read it. Okay. Docker pull images or software. Could you tell me where is it downloading from? It is downloading from what? Docker Hub, which is a default registry. It is not a repository, it is a registry. Okay. సో అన్నిటికీ ఒకటే టర్ములు వాడకండి. ఓకే, అలాంటప్పుడు మీరు సపోజ్ ఇదే మీకు ఇది ఎంత అసహ్యంగా ఉంటుందంటే, ఇప్పుడు సపోజ్ ఒక డాక్టర్ ఉన్నాడు, 2 డాక్టర్లు మాట్లాడుకుంటున్నాడు. ఓకే, ఒకటి జంతువుల డాక్టర్, ఇంకోటి మనుషుల డాక్టర్. మనిషికి వచ్చిన రోగాల గురించి జంతువుల భాషలో చెప్తే ఎంత అసహ్యంగా ఉంటుందో, రైట్? So for the people who didn't understood it, let us assume that 2 doctors are speaking. One is veterinary doctor in there. The other one is a normal doctor. If the veterinary doctor starts speaking about human diseases in the animal terms, will it be okay? Right? Yeah, that will be exactly the same thing. So don't mix terminologies. Right? In Docker we don't have repositories. In Docker we have a registry. Right? Okay. Right, can you please explain? Not clear. Storage not clear. Okay, storage layer thin. Okay, when I say thin, it will not have 0, it will start with 0. As your container is writing data, the space of it will increase. Okay, it will start with 0. Okay, okay. Storage size not clear. Go through the whole documentation, read it. Tomorrow I'll start with that discussion. I would expect you guys to do some effort. Okay, right. Is there any possibility of base image layer corruption? There could be chances. So for example, someone has messed with varlib folder. Okay, but understand one thing, whenever these kind of things happen, okay, they happen very rarely. Okay, they happen rarely only in the cases when you really want to corrupt that images and then try something else. Right? But generally, you will not see that happening. I've never seen that happening in production system, at least, because the way Docker handles it is different. It is not present. They are in the encrypted format. You cannot go and mess it up. Yeah, if you are a root user and if you just say that echo and then do something to that file, that's a different story. But ideally, until unless a root user messes with it, there is no way that they are going to getting corrupted. They will be corrupted when you want to corrupt it. Okay. In that cases also there is a way to basically revert back. Just to pull the image layers again. Yes. Storage size is not clear. Mohan Reddy asked me 1,000 times again. My answer is read that documentation. Okay. When we will start OpenShift? We will start it from tomorrow also. Tomorrow itself. Let us stop Docker. Let us finish OpenShift. Okay. You will not be understanding OpenShift class. By the way, OpenShift I have not told the terms and conditions, right? For OpenShift there is one term. I will be giving you an exercise in Docker and Kubernetes. Only the people who have done it are eligible for OpenShift. Otherwise, no OpenShift. So first worry about that. Yeah. మీరు 100 సార్లు అడిగినా నా సమాధానం అదే. Can I use same containers for day-to-day deployments? Yes, absolutely. Okay. But the point is, whenever you create containers are not important. Image is important first. Because containers can be created. So for example, let me tell you a simple use case. We are running Spring Pet Clinic. Due to some reason, Spring Pet Clinic is down. Okay. One way is you can go and fix it. Other way is bring one more Spring Pet Clinic container. Because creating a container from an image is very, very fast activity. So even if some server goes down, bringing one more server is a difficult job. One container goes down, bringing the same container alive is an easy job. Okay. So we'll be using the same containers, but for this, image is important. And remember, I've said one important thing today. Whenever your containers die or they are deleted, they also thin layers where they have changed some content are also deleted. If that content is important for you, then we have to deal differently. If that content is not important for you, then there is no problem. There is no need for you to identify as long as you change. So for example, you have started a Spring Pet Clinic and Spring Pet Clinic has started writing logs to some directory. Thin layer is created. It is basically doing the activity. So do I want those logs or not? That same thing. You have an inspect and that inspect, you rather than passing an image ID, pass a container ID. Right? Okay. Fine. Does all the file systems happen in memory? Man, when did I say it? File system happen on disk itself, not on memory. I never said file system is happening on memory. Right? File systems are basically mounted from disk itself. Nenu eppudu annana memory ani? No. That's the reason why I have dealt storage separately from CPU and RAM discussion. If you remembered, we have discussed Docker internals where I have not touched too much about storage. Today I am speaking about storage. This is all disk. There is no memory loading. If you want to do memory loading from a storage, in Linux we have a concept called as swap memory. You have to use the same thing in Docker also. Right? Because Linux consists of, or Docker consists of a Linux kernel internal. So whatever you do for Linux can be done in Docker container also. Right? Okay. Fine. Okay then. I'll stop it at that. And then please go through the content till copy on write strategy. Okay. I've given a link of official Docker documentation and I would expect that everyone goes through that documentation. Alright? Okay then. Thanks.